Are we good now? The box is gone. Okay. So we think of ethanol and water are alike. Hexane and benzene are alike, but hexane or benzene are not like ethanol and water, so they would not mix. So we introduced 2-propanol, which is my favorite solvent. It's a really interesting and very useful solvent, and most of you have this in your house. Where do you have it? Do you know? In the bathroom. What do you do with it in the bathroom? Could be a loaded question. Yeah, you disinfect wounds because it's rubbing alcohol, okay? 2-propanol is isopropanol or isopropyl alcohol, rubbing alcohol. And we disinfect wounds because it feels so lovely when you pour that into an open wound, right? Hydrogen peroxide disinfects wounds too, and it doesn't feel as awful. So I actually use hydrogen peroxide for disinfecting and getting blood out, but I use isopropanol at home for its solvent capabilities. So the 2-propanol, what does prop mean? How many carbons? 3. So we have a 3-carbon hydrocarbon. The 2-propanol means that the hydroxyl group, actually I'm going to redraw that because I didn't draw it nicely for showing the shape. So we have the OH up there, and then we have carbons here, and a carbon here, and a hydrogen here. So now when we look at this, I want you to start thinking about the shape of this molecule. What is the bond angle right here? What is the steric number for carbon, or how many electron domains does carbon have? 4. So when we have 4 electron domains, or the steric number is 4, what's the bond angle, Nick? Not 90. It's a little bigger than that. Not 119.5, not quite that big. 109.5, the tetrahedron, remember? Okay, sometimes you'll see it on paper and it looks like 90, but it's not because it's not flat. It's in 3-dimensional space. So these are all 109.5 because these all have a steric number, also called electron domains. It means the same thing, of 109.5. So what that means, the way this is angled around, you have this big clump of hydrocarbon down here, and up here you have the polar hydroxyl group. So isopropanol can go both ways. It can dissolve easily in nonpolar solvents because of the nonpolar area down here, and it can dissolve in polar solvents. So it's really a useful solvent in the laboratory. And in the house, it's really great. In the lab, if you have equipment like a pump that you're using to deliver liquids and you've been pumping hexane and now you want to use that same pump for water, you can't just put water in there because you'll get the water and hexane making an emulsion and it'll be a big mess. So what you do is pump isopropanol through there. The isopropanol will mix completely with the hexane, flush out the pump. Now your pump is full of isopropanol. Now you can pump water. So it's a great solvent in the laboratory, and at home it's even better. When you're in the kitchen and you knock over the bottle of vegetable oil all over the floor, after you've done sopping up the main mess with the paper towels, then you still have that greasy residue. The isopropanol will cut right through that and remove it, and it'll really clean things nicely. It also works nicely to clean up adhesives. When you buy a picture frame and they put the price sticker right in the middle over somebody's face in the photo, and then you're trying to pull that off, you have that adhesive tape residue. Isopropanol gets that off very nicely. It'll dissolve that too. So it's a really, really handy solvent because it can go both ways. Now, when we make liquid-liquid solutions, they just kind of have to spread apart. When we make solid liquid solutions, we have a little different thing going on. And we have the solid molecules, or the ions, if it's an ionic compound, become totally surrounded, or the solid, not the solvent, the solid, or the solute, becomes totally surrounded by the solvent molecules and dissolve. And when we have an aqueous solution means that water is the solvent. That's what aqueous means. You remember aqueous from Chem 111? Remember when we wrote things like HCl-AQ, and that was hydrochloric acid because we were dissolving hydrogen chloride gas in water? The AQ means dissolved in water. Then instead of saying it's solvated, we say that it's hydrated, or solvation becomes hydration in aqueous solutions. Now, when you start to think about this, we want to start for the very first time really thinking about things on the molecular level. We're going to do a lot of thinking on the molecular level in Chem 112, and I'm going to be asking you repeatedly, what's in my beaker? What species is in my beaker? So when you think about this, when we put ionic compounds in, they consist of cations and anions arranged in a lattice. So I'm going to quickly draw sodium chloride, just some random sodium ions, chloride ions, all arranged in a lattice somewhere. Now, when we dump this in water and we want it to start dissolving in water, what happens is the water molecules come in there, and you remember water is polar. It's got a 105.5 degree bond angle, so it comes in here like this. Now, the water is charge separated. You have a partial negative charge on the oxygen and a partial positive charge on the hydrogen. So what happens is this oxygen actually interacts with the positively charged sodium ion, and it pulls it out of the lattice. So now you've got this sodium ion floating around in solution, and it becomes hydrated or completely surrounded by water. The water sort of surrounds it like this, with the oxygen end of the molecule, the partially negative charged, end in, and the positively charged, partial positively charged hydrogens out. Okay, I kind of think of this like the elephants protecting the baby when the lion comes. Okay, you got the elephants hanging out, doing their elephant thing. Yes? Oh, gosh, yes, thank you.